our class. Let me just to confirm the groups. Because we start our lab today, our labs today will do the first lab. So I just want to make sure about everyone knows his or her group as a coordinator. So let me share with you this slide. Okay. Bilgin, please. Bilgin, please the same thing. Don't go back and forth. Stay in the class. Don't go back and forth to avoid interruption, please. You may go outside of the class, and when you come back, I don't see you to let you enter. So please. Okay, guys, everyone sees these groups here?
Yeah, I see him.
Okay, good. Yeah, okay. So we spoke about the coordinators last time. So for group one, you choose bank as your coordinator. So everyone is okay with that? Please say yes, say no if you have any comment about this. So okay with bank? Group one. Nermin, Anzaldo, Belgin, Casto. Everyone hear me?
Yeah.
Yeah, I hear you clear.
Yeah, I can hear
Okay,
you.
so you see the members of group one. This is group one. You see the members? I mean, every member see his name in the group one. The members of group one. You agree about Bang as your coordinator? We can change Bang if you like, no problem.
No, we agree. We agree.
Oh, okay, perfect. So please, Bang, send your email to your group member, okay? Bang, do you hear me?
Yeah, I hear you.
Please send your email to the group member, okay? Okay? You must communicate with each other. As we mentioned, the labs are group submissions. Again, the labs are group submission. So one submission per group, but everyone in the group must participate in the lab. The coordinator will organize the task of the lab, and the coordinator who will submit the lab, he will write the group number, and he or she, and the coordinator will put the percentage of participation of each member. So if one of the members say participate with 50%, so if the grade of the lab 100, and this member see his grade like 50, and the other members 100, for example, so you should know why, because your participation was low, based on the feedback from the coordinator. This is, by the way, it's called uh, peer grading, and this is official grading too for the people work as groups. Okay, so please coordinate with each other, mainly with the coordinator in your lab, because he will put the percentage of your participation. Is this clear for everyone? Any question here?
No question.
Okay. Group two. Okay, you choose before you choose Castro as a coordinator. If you wanted to change, I confirm the coordinators today. Okay. So if you wanted to choose someone else, and you all of you agree about this guy, so I can change if you like. So okay with Castro group two?
I'm okay with him,
Okay.
yes.
I'm okay.
Okay, perfect. Please, Castro, send your email to your group. Okay? Castro, you hear me?
Okay. Yeah, Professor.
Okay, thank you, sir. Thank you. Group three, loss. You choose the loss. Initially choice as coordinator. So are you okay with that? Group three?
Yeah.
Okay. Loss. Do you hear me? Loss, the coordinator.
Yeah.
How you say your last name? Scalante?
Los Escalante.
Scalanta? Scalanta.
Yeah, that's fine.
Yeah, please send your email to your group. Okay? Okay? Chat with them. Give them your email address to communicate with you. Group four. Group four. Last time you initially choose Christian. So are you okay with that? Group four?
Yeah, I'm good.
Yes.
Okay, good.
Yeah.
Thank you.
Yeah, that's fine. He seemed pretty chill.
Okay, good. Okay. Each coordinator, you are responsible for your group, okay? So you must submit on time of everything, right? Group five. Group five, Hamza. You choose Hamza as your coordinator. Are you okay with that? We can change if you like.
Yes.
Okay, if we can change if you wanted to change. Okay. Okay, good. Thank you. Hamza.
Yes, boss.
Yeah, please send your email to your group, okay?
I just did.
Okay, perfect. Thank you. Group six. Group six. We didn't choose the coordinator for group six last time. You didn't give me the
Professor, it was me, Rahman, 29.
29?
Yeah.
Rahman? Okay, hold on a second. Guys, you agree, group six?
All good.
You agree about Rahman as coordinator?
Yes. Yep.
Okay, good. So you looks like you are popular guy, Rahman. Okay, just you. Okay, coordinator. Like social, yeah. Okay. Okay, so these are your group, one submission per group, with percentage of each member, how much contribution, like 100 contribution or 80 or whatever. This determined by the coordinator. Okay, so this gives you a good chance to communicate with each other as group and exchange ideas, because we believe also group or teamwork has a lot of benefits than individuals. But as we mentioned, for the assignments, this individual submission, like any other tasks except the labs or projects, is group submission, but other than this is individual. For group 3, Los, do you hear me?
Yes. Yeah.
Yeah. You have one member here, group 3. Yeah, group 3. You have a member here, didn't show up so far. So this means if there is no contribution, we'll wait like another 1 or 2 sessions and will be dropped. So if this guy didn't show up so far, so this means if there is no communication with you, expected to give 0%,
Okay.
since there is no contribution or participation in the lab. Okay, I just highlighted because unfortunately didn't show up and didn't say anything. Okay. Okay, guys. Any questions? I will post this today after just we finish the lab or before even. So do you have any questions here, please? Before we go to the lab? Any questions? Okay, thank you, guys. Thank you. Okay, so let us just share the lab first. Okay. Okay, everyone sees the lab?
Yes.
Okay, good. As we mentioned, for our labs, we will use Multisim. It's very professional software for circuit simulation. So because we do the lab virtual, so most like our work is simulation. Simulation is actually essential part of any design, of circuit design. So usually okay. The design process usually go through these steps. You take the task as like a group or team in your company. You have been asked to put a design for whatever, for system, a specific system. So usually you are given some data, some values, and there are other values unknown. So you start with determining these unknowns through using equations related to your design. So you start with mathematical formulation. Formulation. To determine unknowns. So this is the first step. You look at the equations. Yeah, we can use these equations to determine the unknowns. So say, for example, if a certain case, you don't have all equations you need to get these unknowns. So in this case, you use numerical technique, the numerical approaches to get whatever the unknown. So at the end, you get the values of these unknowns. So you have all values, all input parameters you have. So you start by modeling. After you get the unknown, you do modeling. Modeling means you draw the circuit on the paper. You draw the circuit on the paper which satisfy these unknowns or input and output. Or like you satisfy the truth function, the truth table. Truth table, for example, is you have certain inputs, you need these outputs. So you put modeling means you draw the circuit on the paper. The next step, you do simulation. Which you take this circuit, which you draw in a paper, you put it in the simulation to check the function. So you see the process of the design. Mathematical formulation, then modeling, then simulation. So what is the benefit of simulation? This, when we reach to simulation, like we reach up to more than 85 or around the 90% of the task for the design. Through the simulation, we check the function of the circuit we did, which satisfy our requirements based on the input data we have and the output function we need. The advantage of simulation here is if you need to change something, like you will see, just click on the software. This resistor, I need to change the value from 1K to 200 ohm, for example. Just one click, you can change the value. No, I need to change this component. Just one click, you remove the component, another one click to add the new component you need. Any other clicks to change the values of this component, like whatever values you need to use. And you check the function, you check the out. So it's very reliable approach to check or to verify the function of your design. If we don't have simulation, for example, let us after simulation, what we do? After we check and adjust our circuit, so we go to prototype. Prototype. Like now you put this circuit on a board. Prototype, wire wrap. Prototype. And then we do another test for the prototype. And this like the last test to verify your to verify your design. The prototype, after we do simulation and they check that everything is fine, so we carry out this circuit on the board. This circuit on the board. And now we have real circuit, real system. And then we need to use equipments to measure the values and to check the function again. So if we don't have simulation, what we do after modeling, we'll go directly to the prototype. And now we check the prototype, or we need to change this resistor, for example. So, oh, John, please go to the store and change this value, bring this value. Okay. Then, oh, we need to change this component. Oh, John, go to the store, please, and change and bring this component, and so on. Any change, we have to go to the store and pay money, more money, and waste more time. And in engineering or most fields, time means money. You waste your time, you lose money. Okay. So to save time and your design be more reliable, so simulation is very essential part now. So why after we do prototype, we have to do another test again? In simulation, you may use values, not standard values, because escalate and change the value for whatever you need. So, for example, say for simple things, resistor. Is this resistor like 1K.2 or 1K plus minus 5%, the tolerance? You choose a value is not standard, not exist on the market. Not standard, the standard values is listed, which you have it in the market. But when you click to satisfy your simulation, you may choose the values not standard. But when you go to the prototype, this value is not exactly the same or little difference, because this is what we have in the market. So this may change the output function you need. So we have to do, after we do the prototype, we have to do another test using the measurement equipment. So actually, for virtual classes, we stop at the simulation, which, as I mentioned, is significant part of the design. And not satisfy the lab 100%, of course, because we don't go to physically to the lab, but by simulation is fine. I mean, it's okay, based on the other needs, like you need to take this course as like online or virtual. So we have to pay something here in front of this. Okay, but this is the process of the design. So simulation is very important part. And now any publications, actually, any publications before, if you look at publications for as a result of research, before, so you see a lot of mathematical analysis, and now things get more complicated. Like we have new materials, very complicated composite materials. So is like the mathematical formulation like before is not available, most likely now. So most of the research now depends on two things, like a background about the topic with few mathematical forms, and the rest, most of the rest of the research or the paper is simulation and measurements. So I mean, simulation now is very significant part of the design process. So we need to understand what we are doing, and we have very powerful tool here for circuit simulation. As you will see, very helpful. You have everything in the software you need. So we need to get the benefit of this. So please, everyone in the group members, do your best in this labs. In these labs. Okay, so our lab here today, we spoke about basic digital gates like OR, inverter, and OR, gate, and AND gate. So we'll do the lab about this. So the objective of the lab to verify the truth table for the basic logic gates. As I mentioned, mainly inverter, AND gate, OR gate. So construct and test the logic circuits. The parts we need here, of course, virtual parts is very similar to the true parts, except just you don't touch the IC, but it's very similar. 7404, this IC 7404 for inverter, 7408 for AND gate, 7432 for OR gate. And the LEDs like these ones here, which indicate if the LED is on, so you can see this light here. If the LED is off, you don't see the light. LED is on indicate that the output logic is high or bit 1. LED off means the output is bit 0. So when we measure for measurements, because we have tables here, we need to fill it out. So say if the output calculated by calculation, if the output is 0, this means this LED is on or off. What do you think?
Output 0, then off.
Off.
Perfect. What's your code, sir?
Mine is 7.
7? Yeah, okay. Thank you, Gary. Thank you, Gary. Okay. Yeah, if bit 0, this means the measurement here will be off. If bit 1, the light will be on, so the measured here you put on. Okay. So this is inverter here. This IC represent inverter. The IC has more than one inverter. Maybe 4, maybe 6. So this one hex means we have 6 inverter here. So if you go inside this IC, we have actually this connection inside. So these inverters here, we have 6 inverters, and the pin numbers indicates where is the input and where is the output. Where you put the input for the first inverter, which pin 1, and where you take the output from. Pin 2 here is out. So to put this inverter under function, you have to insert the input here, either bit 1 or bit 0, and you see the output from point 2, from pin 2. Physically, when we have the IC physically in the lab, the pin numbers are not listed on the IC. Is not listed on the IC. But we can figure it out. How we figure it out? You see this mark, this knob here? The first pin on the left of this knob is pin number 1. then bin number 2, then 3, 4, 5, 6, 7. Go the other side in this sequence, then 8, 9, 10, 11, 12, 13, 14. Most likely, if we have 14, because there are ICs with different number of bins. For 14 bins, most likely bin 7 connected to the ground, and the bin 14 connected to VCC. VCC is actually represent logic high or bit 1. 7 or the ground actually represent 0 connected to the ground, it means 0 volt. So represent bit 0 or logic low. In simulation, here we connect, as you see here, ground here is connected to the ground. The bin 7 here is connected to the, this represents the ground here. And this represents VCC. And the bin 14 here, if we go 1, 2, 3, 4, and so on, so you reach it to bin 14. That's connected to VCC, which is 5 volt. Most ICs 5 volt, or between 5 up to more, most likely 18 volt. In simulation, if accidentally we forget to connect bin 7 to the ground or bin 14 to VCC, by default is connected. In the simulation is software. The software. So by default is connected, but I show you here, I insisted to connect it to see complete connection for the IC. But physically in the lab, if you missed to connect the ground, or you missed to connect the VCC to bin 14, the IC never work. You must connect ground and the VCC for the IC to work. So I mean, if for any reason you forgot to connect the ground in the simulation and the circuit works, this never happened in the practical lab. You must make sure you connect everything, because this is the biasing of the IC. And in simulation, as I mentioned, is already by default is connected. But physically in the lab, you must connect it to make it work. This is a switch, as I will show you in the simulation. And when you click on this, it moves from this board to this board. So if the switch moves and connected here, so this means you connect bit 1 to the input. This is the input 1A. 1A here. A means gate A. Inverter A. So 1A is the input, and 1Y, which is bin 2 here. The second bin here, which is 1Y, means the output of this gate. So the output, as you see, connected to the LED to measure the function. And the other side of the LED connected to the ground. So we need to, you will use this document for your lab and fill out these tables. So for example, here, say 0 as when we as calculation. If we put 0 as the input for the inverter, what is the output?
1.
1, perfect. So 1. So what you expected for measurement is on or off?
On.
On, perfect. And so on. So this just example for how you give me the codes, please. What's the codes? Your codes, guys?
10.
27.
7.
And
Okay. And what?
10.
27.
10,
10.
10, okay. One
And
more, one more person. Who?
27.
27. Okay, thank you. Okay. So this is just a sample for how you fill out these tables. This is OR gate. And you see, if we go inside here, this is the OR gate. The bit number is 74. These are standard numbers. Is produced by manufacturers, different manufacturers, of course, like Texas, many companies, but this is standard number. And each IC has a data sheet. The manufacturer is provide a data sheet for any component, digital component or ICs. And let me show you example for that. You can Google it. It's easy to Google it. Just put the number here and write the data sheet. Google it. You can see, you can get different resources for this data sheet. So let me show you one of these data sheets here. Okay. You see this? You see this data sheet?
Yes.
Okay. So these all the same standards for inverters. All these numbers are equivalent. So you can see here, this is the mark here, the node I mentioned. So you put the IC in this direction, and then the first pin on the left is pin number 1. Then 2, 3, 4, 5, 7. Go to the other side in the same sequence. You get 8, 9, 10, up to 14. So this is the pin numbers, and you have all data here. Of course, there are more data. May we not use it right now, but definitely people use it in other applications. And this is what inside this IC. The first pin 1A is the input. The second pin is 1Y, which is the output of the first gate. Then 2A, 2Y, 3A, and so on. Everything, logic level high equal to what? Logic level low equal to everything. So each IC or digital component actually has data sheet, must be provided by the manufacturer. Okay, any questions here? I'll just show you a sample, but you can get any data sheet for any of the ICs we use. Any question here? Any question?
Is this data sheet like linked on Canvas or do we have to look it up?
What is that?
Is this data sheet linked on Canvas or do we have to look it up ourselves?
No, you can get it. You can Google.
All right.
You can Google, just Google, write the number of the data sheet, the number of the IC, and ask for data sheet. So put the number and the data sheet. Run, you will get different companies provide you this data sheet. So I just show you example, but you can you can Google it and get what you want.
Okay, thank you.
You're welcome. Okay. Now let us go ahead. Here, just 1 second, please. Okay. Okay. So for this inverter we done for OR gate, What is the function of the OR gate we mentioned? Who remember? What is the function? Zero,
It
0, 1 at the
Right.
inputs. It gives what at the output?
0.
1.
Oh.
So what is the general function of the OR gate?
Logic addition.
What is that?
Logic addition.
Perfect. Thank you, sir. What's your code? Don't tell me 7.
31.
31. Okay. 7 has a lot. Okay. So I hope everyone has the same. 31, Riley? Riley?
Yep.
Okay, thank you. Riley has good participation so far also. So I tell you the people who have good participation. 3, Bang.
Ibrahim.
7, Chin. De Souza, 10. 15, Hatter. Not bad. Travis, not bad. Emily, not bad. Gabriel, not bad. Grant has good participation so far. Stephen, not bad. James has good participation. Riley has very good participation. I hope everyone please to participate. Don't hesitate. Participation is good for you. Okay. And as I mentioned, we all learn. Okay, so don't hesitate. Okay, so this is OR gate. As we mentioned, this is logic addition. The function is logic addition. Let me write it down here. Oh, okay. So this logic addition. Okay. Please, as I mentioned, it's maybe you need to put notes or get a screenshot for this or photo for this to use these notes. Okay. So what happens here? As you see the connection here, 1A, which is the first input, which is pin 1 here. Then pin 2 is 1B, which is here. Based on the numbering system, 1, 2, 3, so 1, which means equivalent to 1A, 2 is 1B, and the output at pin 3, which is 1Y. So 1Y is connected to the output. 1A is connected to a switch, such that we can change from 0 to 1 or 1 to 0. 1B is the same, connected to another switch. So this 1A connected to what? As you see here, 1A is connected to bit 1 or bit 0, or logic high or logic low?
Logic high.
Logic high. Perfect. What's your code, sir?
10.
10. Oh, 10? David?
Yes, sir.
No, Arthur.
Arthur.
Oh, okay, thank you. Okay. Logic high, because you see the other side here connected to VCC. Bin 2 or 1B connected to what?
0.
0, exactly. It's connected to the ground here, which means bit 0, right? What's the code again?
21.
21, perfect. 21, Hamza?
Yes.
Thank you. Thank you. Okay, so this means we have 1 here and 0 here as inputs. So what is the output you expect?
0.
Man,
1.
1. 1 plus 0 is 1. Logic addition. 1 plus 0 is 1. 0 plus 1 is 1. 0 plus 0 is 0. 1 plus 1 is 1. So, and so on. We need to change the inputs we have four combinations. We have four combinations here, right? These are 0, 0, 1, 0, 0, 1, 1, 1. So, for example, again, let us say here, or let us say here, anyone. I just change what we have. So, for as calculations, what is the output here?
0.
0.
0. Perfect. What's the code, lady?
20.
20. Emily, thank you. 0. Yeah. Of course, we encourage our women in engineering. So, yeah, thank you. Okay, so what we expect for measurement? If the output by calculation is 0, what we expect to see at the in the measurement?
Off.
Off.
0.
Off. Perfect. Thank you.
Off.
Off. Okay. Perfect. What's your code, sir?
28.
What is that?
28.
20. 28?
Yes.
Stephen? 28? Stephen?
Yes. Stephen, yes.
Yeah, okay, thank you. Okay, and so on. You continue. 1, 0, whatever. So, beside this table, you need to put screenshot for your measurement. I will like based on the connection, of course, like 1, 1, for example. 1, 1 will be different than this. The screenshot you put is your own screenshot. Don't copy these ones. You put your own screenshot. So like 1, 1, this connected to 1, and this also connected to 1. And we expect to see here the light is on. So you put a copy of at least one screenshot, different than what you have here. Okay, to get full grade for your lab. Then and the gate, which we mentioned. What is the function of the AND gate?
It's a logic product.
Logic product. Perfect. What's the code, man?
Also 20 again.
21?
Just 20.
20. Okay. Thank you, Emily. Thank
Yeah,
you.
of course.
Thank you. Okay. So AND gate, as Emily mentioned, is logic multiplication. So means 0, 1 is 0, 1, 0 is 0, 0, 0 is 0, 1, 1 is 1. The same, the IC number here for the AND gates is 7408. Okay, there are letters you can see inserted in the number. Don't worry about this, just the version number. Versions. But the important thing is the number of the IC. Like here, for example, is 7404. This is the most important, 7404. LS is just versions. And here 74 for OR gate 7432. For AND gate 7408. Then again, connected to two switches to change inputs, either 0 or 1. I will show you how we get these switches when we go to the simulation. But I just explain the concept here now. And we can change the inputs to see the out. So, for example, what we expect to see here, for example, 1, 1. As calculations, what is the output here?
1.
1.
Zero.
ما 1. Who said 1?
Me, 29.
29? Thank you. 29? Rahman?
Yes.
Thank you. Okay, good. We have new participations here. Okay, perfect. So 1. So what we, in the measurement, what we expect to see?
On.
On. Perfect. Thank you. What's the code say? Who said on?
27.
Okay, thank you. And so on for the rest. At the end of each lab, so as I mentioned, you fill out these tables based on the examples we did here. You add screenshot, at least 1 for each case, differ than what you see here. Like say, for example, here in the inverter, we connect the input to bit 0. No, now when you post your screenshot, I need to see this switch connected to bit 1, not bit 0. Again, here also different inputs. I wanted to see different inputs than this. At the end of each lab, I need to put your conclusion or your comments. Why this part is important? Because when we do measurements or simulation, we may discover something. We don't see it before, for example. Something remarkable. You know, people discover the formulas, scientists or researchers discover the formulas based on the measurements, either simulation or in the lab. They discovered the new formulas based on something they saw and searched it, and they got formula for that. So we need to have a habit for when we do a work like this, we can put a conclusion or we can put our own comments. So your conclusion are just a few statements, like 3, 4, 5 statements maximum. You say if there's something remarkable, just put it immediately. If not, so just briefly mentioned what you did here in the lab. So for example, just for example, I may say here, oh, in this lab, we can see the inverter has only 1 input, for example, has only 1 input. However, for AND gate and OR gate has two inputs. This is like something you see here. And I mentioned in the class, except the inverter, like AND or exclusive or whatever, they may have more than 2 inputs, and this is called expandable gates. But for the lab, we just see 2. Then you may say, in this lab, we verified the function of basic gates, or gate and gate and not gate, for example. Okay? So something like this, but it is up to you. It's up to your group, what you see, okay? But again, few statements, just a few, not write like 1 page or 2 pages, no. Just a few statements to give me your conclusion. Okay? Is this clear for everyone so far?
Yeah,
Yes, sir.
makes sense.
Yeah, it looks good to me.
Yes, sir.
Okay, perfect. Okay, let us now go to Salah. How we do this? Okay. Okay, so let me just, everyone sees this screen?
Yep.
Yep.
Okay, let me just,
Oh, Professor, I have a quick question.
yes, sir.
So the coordinator submits the lab, like only one person submits it?
Yeah, I mentioned is group submission, not submission for each group.
Okay, so but
By
yeah,
by the coordinator.
okay, so only one submission then for each group.
Yes, okay.
Okay, thank you.
Okay. I actually I put all the three parts. I mean, or gate inverter or and in one screen here. But you can do the same, or if you prefer to do every one individual, is up to you. But you can put all of them together here. So how we get, first of all, how we get these components? Let me just give you a quick hint about this multisim. If you look at the, first of all, you can, if you look at here, you can get any component you need. You see this? Like here, resistors. We can get any resistors we need. Okay. Any component, diodes, ICs, whatever. Okay. So from here, we can get the components we need. If you look at the right side, if you put the cursor here, what you see? Multimeter. You can drag multimeter, but we don't need it here. We use it actually for the other class, circuit analysis. But this a meter to measure, like exactly you are in the lab with physical equipment. So the meter here do the same thing. Here you can see function generator. You see generate sinusoidal signal or analog, generate digital bits like clock pulses, generate sawtooth. So three functions can be generated. Use this, like if you connect this to scope, you can see these functions. Again, this for analog, not for this class, but I just to give you idea. Sorry, about what we have here. Then watt meter, scope, you can see any, you can display any output function here using the scope. And this also we use a lot in the other class. Okay. And so on. Any frequency counter, digital analyzer, everything. So any component, any equipment you need to use or display the output function, how it looks like. So you can use these equipments you can drag any equipment as I did and put it in your screen here. Okay. So now I need to create this circuit here for the inverter. So what we need? We need VCC, we need ground, we need the IC, we need the switch, we need the LED. So we drag the components first, and then we connect them. So we need VCC. The VCC is just related to the power source. So if you click on this, you see this one here, a symbol of ground, place source. So if you look at here, so you can see DC power, ground, and so AC power. So if say we need the ground, so click on the ground. There are two symbols for the ground. This one, which actually most likely we use, so we drag it here. And this one too. It's the same. But like most likely we use this one. But there is no difference. We need VCC, so if you click on DC power, so you can see here VDD, VCC, VEE, VSS. VCC, yeah, I ask you the question first. 7-4, you see the IC start with 7-4, with number 7-4. So this means which technology we use here? TTL or Siemens?
TTL,
TTL, perfect. What's your code, Sam?
31.
31, perfect. Thank you. TTL, because if you remember in the class, we mentioned TTL start with 74, most likely. 74. CMOS start with letter C. So this is TTL. For TTL, we use bipolar junction transistor. The transistor I draw when we talk about the inverter is called the bipolar junction transistor. We have base, emitter, and collector. The collector, we use letter C to refer to the collector. So that's why we have VCC. If we click here, we get VCC. So, okay. So we got VCC. VCC means the voltage applied to the collector, the biasing voltage here. So that's why we have VCC here. You can see we have also VEE and we have VDD. VDD is the same, but I mean the notation here, VDD, this actually used for Siemens. Because in Siemens, we have, instead of the base, we have gate. Instead of the collector, we have drain. Instead of the emitter, we have the source. So that's why you see here VSS, the source. VDD is the drain, for the Siemens. But it's a value of voltage. So one may say, oh, so if say I used here VDD as 5 volt, does this make difference? Of course not. It's just a voltage value or logic high. But the notation, I try to explain the notation for you. Why here VCC? Why here VDD? VDD refers to the drain in the CMOS technology. VCC refers to the collector in bipolar junction transistor, or TTL. VDD used for field effect transistor. Okay, so we just need here VCC and the ground, and now we need also the switch. So again, if we go here, so if you click here for basics, so you can see the switch here. Okay. This kind of the switch, which has 2 bolts here, is called SCBDT. SCBDT. There is another one here. It's just 1 bolt. We don't need it. We need this one, SCBDT. So we have it here. So click OK. So we got it here. Okay, perfect. Now we need the IC. The IC, if you click on TTL here, you can see here TTL. Click on TTL. So you can see 74LS, which is letters we use here, IC. This one which we need to click on. One may say 74LS here, just without IC. This gives you the gate, not the IC. It's just one component inside the IC. We use it for other analysis, okay? But we don't use it for this lab here. So we have to click on 74LSIC. And now we need the number 7404. So you may look at 7404 is here. 7404. So we click OK, we drag it. So 7404. Perfect. We need the LED. The LED means the diode. So the diode is here. If you click on place diode, so you can see the LED. And you can choose whatever you like red, yellow, green. Okay. So I choose red, actually, it's just my choice, just to make it more clear. And click OK. Okay. Did we got everything? Yes, I think so. Ground. Yeah, okay. So we drag all components here. Okay. Another way to drag the components also, either you do like I did, or also if you go to if you click on no, all groups here, all groups. So this also gives you everything. So you can choose whatever you need. Okay, so for example, lids here, if you click lids, you get the same thing. And so on. So either you go through these here, this gives you direct to go directly to the components you need, or put just all groups here and you can have everything. So just pick up what you need. Okay, now we got the components. We need to connect the components. So little organization first we need. So we may move this little bit here. So you just click and move it. Move this little bit here. Okay. And then the switch, may we put it here. And IC, may we put it here. And the lid, may we put it here. This is your organization. Okay. Now look at the position of this switch. You see the switch here? Now if I click on this, it moves on the bar here, it moves from bit 0 to bit 1 as input. So we need to change the orientation of this switch, such that this part here connected towards the IC. I mean the location. So just right click and you can rotate here. The rotation here actually is 90 degrees, so it's okay. We can do it in different times. Another rotation. So we got the right position for this switch. Now we need just connect this here. Okay. And let us move this little bit here. Okay. So the other one connected to here. And this is switch connected to the first input. And the ground here is connected. Let me just, it's better here to let us move this little bit here. And this the other side of the lid connected to the ground here. Then this is connected to the ground. Okay. And then VCC connected to this one here. Okay. And the output is 1Y. It's connected to the lid. Okay. So this is a connection. To make this work, I mean for operation, you see this green arrow here, just click. So what you see here, the input is connected to what? Logic low or high? 1 or 0?
1.
On.
So what you expected as the output?
On.
As the output. What you expect? The output.
On.
Be off.
The inverter. If we put 1 in the input, we get 0 at the output. Inverter. We invert the input from 1 to 0 or 0 to 1. So if we have 1 here, so we get 0 at the output or off. If we change the input to logic high, logic low, now the input is connected to logic low. So what you see, 0 inverted to
1.
1. So the lid is on. Okay. So again, go to logic high. The input connected to bit 1, so we get bit 0 at the out. Bit 0 at the out means the lid is off. Change the input to bit 0, inverted at the output, so we get bit 1, or the lid is on. Is this clear for everyone, guys? Please, if you have any confusion, let me know. Tell me, and we can go back and explain it again. Okay, thank you.
If I may
Yeah.
just ask something,
Yeah,
will
sure.
we need an upgraded version of Multisim to get access to all these tools?
The multi-sim is offered by the school. You should have access for multi-sim.
Okay, thank you.
Other than this, you buy it. So you should not buy it. I mean, it's offered by the school. If you have any issue with this, please contact IT, the IT guy. And say in our class, EGR 270, we need multi-sim for our labs. If there is any problem, but I don't think so. It's offered because we have also online courses, and always multi-sim is available.
Professor, if I'm not mistaken, you linked it in your syllabus, I think, halfway down. And then if you click that link, it'll prompt you, and then it will say,
No. No, is maybe
It's an important announcement.
is available by the school. Okay. I will check again, and if any update, I will do it on the syllabus. If any more update, I will do it.
no,
But
it's there. I was saying it is there. It's in the syllabus.
okay, anyone get multi-sim? I has access to multi-sim? Tried to check.
Yeah, I already did the
I have
first
it
part
pulled
of
up.
the assignment.
Okay, and you got it, or you have any issue?
It was no problem.
You see, so there is no problem. Yeah, since one student or whoever got access, you can do the same thing. Okay, so you should not have any problem with multi-sim, which is great actually, because this is very powerful tool for circuit simulation. Okay. Any other questions, please? Any other questions? So what we have on the syllabus is updated. I just when you asked your question, I thought that we may have more updated versions, but it's updated. Okay. So this I just deleted. Oh, to do any changes in your connections, you have to turn it off. Turn it off. Just click on the red one here. Now we can delete this. Okay. The same thing you can do for OR gate or AND gate and OR gate. So 7432, this is for OR gate, as I mentioned. So we can see here, OR gate is logic addition, as your friends mentioned. So this is logic high, and this is logic high. So one at the input gives one at the output. It's logic addition. So the gate or the lid is on. If 0, 1, the same, because 1 plus 0 is 1. If 1, 0 is the same. But if 0, 0, oh, sorry. I'm sorry. So we have to 0, 0 is 0. Okay, again, 1, 0 is 1. 0, 1 is 1. 1, 1 is 1. 0, 0 is 0 at the output. For the AND gate, Logic multiplication. So 1 0 is 0, 0 1 is 0, 0 0 is 0, 1 1 is 1. So 1 1 is 1. 0 1 is 0. 1 0 is 0. 0 0 is 0. 1 1 is 1. Everyone sees this? Everyone sees this, please? Everyone sees?
Yes.
Okay, good.
Yes.
Okay, so as I mentioned, for the screenshot, say in the document, I used this, for example. I connected this to 0. So I need you to get screenshot for this. I just want to make sure you go through the lab and you did everything. That's the target, okay? So for each case, as I mentioned, just one screenshot or more or two, just one or two. But please choose different ones than what we have in the document. So for the OR gate, you can take screenshot for everything, but our concern is the OR gate, for example. And then another screenshot for the inverter, then another screenshot for the OR gate, and then another one for the AND gate. It's clear? Everyone see what I'm saying?
Professor, do you want us to take a picture, like a screenshot of it in each state showing the light different, or just one screenshot for each image?
For each case, like inverter, I need screenshot for the inverter. For the OR, screenshot for the OR. But again here, because we talk about if you use the same thing here, like the three ICs connected here in one lab, it's okay. Just when you talk about the OR gate, so our concern about this part, despite we have other parts here. When we talk about OR gate, so our concern here. You see what I'm saying? And get screenshot and paste it in your document. Okay?
Sounds good, thanks.
Okay. As I mentioned, this is the advantage of group or teamwork. You exchange ideas, and at the end you reach to your final submission. Okay, guys. Any question, please? Any question? Is everything is clear? Is everything is clear or not? Any question? Guys, any question?
No, everything seems to work fine.
Okay. We still have time, so please go ahead and work on the lab. I will be with you up to 4:30. Up to the end of the lab. So if you have any question, you can ask me. Okay. So go ahead, please. Create the circuit on the multisim and verify the functions. And if you have any question, please let me know. Okay.
But Professor, if we are squared away at this point, are we good to leave?
Yes.
Yeah, I just didn't want to lose participation. I appreciate it. Thank you so much.
Okay. You're welcome.
Take care, Professor.
Thank you.
You're welcome.
Professor, I have a question about like the
Yeah,
participation thing.
sure. Yeah, go ahead.
So if everyone in the group does like everything, do I just put like 100% for everyone, or do I put like 25, 25, 25?
What is that?
Like like if there's like 4 people in my group, do I put 100% for everybody, or do I put like
Oh,
25, 25, 25?
no, you didn't understand what I mentioned. Your group, what's your group? What's your group number?
3.
3. In group 3, you have David, you have Fatima, you have Ryan, you have Hat. Okay? So if David, for example, his participation, his work with you, say 60%, you put 60%. What is this 60% means? He means his effort in participation is 60%. So if the lab took, if the final evaluation of the lab took like 100, David, I'm sorry, David I don't mean David, anyone. Because his participation, you put 60, so he will take 60 out of 100. If you put 100, so he will get the full grade, like 100. Say another one in your group, you put the percentage 40%. And the lab got 80 out of 100 for whatever reason. So this guy has participation 40%, so he will not get 80, he will get 40. So, I mean, let us say 50. His participation is 50 for simplicity. So he will get 40 out of 80. So the percentage you put is not just to complete 100% as a total. No. The percentage is the effort, reflects the effort done by the member in your task. Is this clear, Los?
Yeah, that's clear. Thanks.
You see what I'm saying, or you see?
I understand. Yeah.
Okay.
Thank you.
You're welcome. Any other questions, please?
Yeah, Professor.
Go ahead.
So I have the first part right here. So when you want us to take screenshots of it, do you want us to take a screenshot of when the switch is in one position and when it's in another position, or just it doesn't matter? Just pick
as I mentioned, choose is better to choose position differ than what I put in the document.
I see.
Okay.
So like the LED off.
Whatever.
Yeah, the LED is on in the document.
Just something differ than what I posted.
Yeah, to prove that I actually built it.
Yeah.
Okay. Okay, thank you, Professor.
Thank you. Fill out the table. Fill out the table I posted in the document.
Oh, and how am I supposed to measure it? My internet kind of went off when you were talking about the multimeter. How do you?
No. We don't use multimeter here. The measured is through the LED, by the LED.
Ah, I see.
If the LED is on, means
1, right?
Yeah, exactly.
Okay. Thank you. Hey, Professor.
Okay.
What does the counted mean? Counted, is that just
Based on calculations, like
oh,
but
just like doing it?
based on
Okay,
the
I
truth
see.
table. Based on the truth table.
I see. Thank you.
Mm-hmm.
Professor, can you repeat that?
What is that?
Could you repeat what was your answer to the last question?
Based on the truth table. We mentioned the truth table, for example, for the OR gate, for the inverter. The truth table shows the input and the out. Go back to our class. The notes I posted. If the input is 0, the output is 1. If the input is 1, the output is 0. For the OR gate, we have 4 different combinations. 0, 0, 1, 0, 0, 1, 1, 1. Based on the truth table we mentioned, and based on the function of the OR gate, which is logic addition, 0 plus 0 is 0 at the output, 1 plus 0 is 1 at the output, 0 plus 1 is 1, 1 plus 1 is 1. So the counted means based on the truth table, or based on what we know about the function of the gate. For the measure is based on the LED. If the LED is on, so this match with the output 1. If the LED is off, this match with the output 0. So if by calculation, if the output is 1, look at the LED is on or off and put what you see. It's clear? Is this clear or no? The one who asked it.
Oh yeah, it's clear.
Okay, thank you.
Professor,
Yes.
you said something about the screenshots. Did you say we had to include our names in it, or I'm not quite sure what you said in terms of the screenshots.
What is that again?
So you said we had to submit screenshots for the
You take screenshot and post it on with the document.
Okay, and in those screenshots, do we need to include a name or something? Or is the screenshot, as long as everything's visible,
Like
just
for the OR gate, for the inverter, for example, the screenshot related to the inverter.
right? So if it's just the inverter, we don't have to have a name or something or anything.
You can put a name.
Okay, I thought you. Okay, all right.
Yeah, I
I'm just
mean,
making
it's,
sure.
it's like under inverter, so this is related to the inverter.
All right,
The
all
OR
right,
gate will be related to the OR gate. Okay.
all right. I was just making sure. Thank
This
you.
this is your organization. Okay. So whatever you see is better, do it. Go ahead. Oh, no problem. Just don't worry about it.
One more thing, Professor. For
Any-
our conclusion, do you want us to talk about any issues we had, or do you want us to just summarize what the lab itself entailed?
As I mentioned, if there's something remarkable, just put it. If not, just briefly mention what you did. Okay, in few statements, like 4 or 5 statements maximum. Got it?
Yes, thank you.
Okay.
Professor, I have a question.
Yes, go ahead.
Yeah, so for the participation percentage, do you want me to like make a table on the doc that I'll be submitting or the comment section of the assignment on Canvas?
No, on the same on the same submission, you put the group number and the member, the name of the member.
You want me to put it on the title or in the document itself?
On the document.
Okay, so I can just make a table.
In your response in the document, you put the group number and the members in your group, and
Okay.
in beside each member, just put the percentage.
Okay, sounds good. Thank you.
You're welcome. Okay, guys, any other questions before we leave? Any other questions?
No questions. Thank you, Professor.
Okay, thank you, everyone.
you.
Have a good day, Professor.
You too. Take care.
Thanks, Professor. Have a good weekend.
Guys. Have a good weekend. Take care. Bye. Bye.